Alright, so here in this video we are asked to find the center of mass of two objects. Here we have little m, which is 3 kilograms. It is placed at x equal to 4. And then here's big M, which is 5 kilograms. It is placed at x is equal to 12 meters. Alright, so this one is pretty straightforward. Here, I want to make a note that I want to reference the origin. So when one is not dictated for you, you should definitely reference the origin where x is equal to 0 or y is equal to 0. Alright, other than that, I'm just going to go ahead and apply the center of mass function here. I'm just going to write out two terms. Here's m1 x1 plus m2 x2 plus dot dot dot. But this particular diagram only has two masses, little m and big M. So I'm just going to go ahead and start with two terms. Alright, so I'm just going to go ahead and treat m1 as little m from left to right. So there's little m, and that's x1. And then m2 would just be capital M here, whatever you want to label it as. So this is 5 kilogram according to the diagram. Alright, other than that, the sum of the masses goes on the bottom. So if you just plug in values, little m, in this case, would be 3 kilograms. It is placed at 4 meters to the right of 0. So the position here is 4 to the right. So mass is 3, x1 is 4, plus m, or capital M here in this case, is 5 kilograms. And it is placed at 12 meters to the right of 0. So the 12 here is a positive value. And then the sum of the masses on the bottom, which is be 3 kilograms plus 5 kilograms. Other than that, 3 times 4 is 12, plus 5 times 12 is 60. So it'd be 60 plus 12, which is 72. And then the denominator would just be simply 8, because 3 plus 5 is 8. So, and 72 divided by 8 would just give you a value of 9. But if you pay attention to units, things will cancel out properly if you have everything in the proper units. Other than that, the center of mass here for this particular diagram would be 9 meters to the right of 0. So here it is in the diagram. Okay, so here's the center of mass, roughly about, I'm not drawing a scale here, roughly about. So from the origin, or from 0, this would be a distance of 9 meters, or 9 meters to the right of 0. Alright, pay attention to reference point. If one is not dictated for you, reference the 0. Okay, alright, here's the next problem. Here's a multiple choice question that I found. It says here there are 3 objects located along the x-axis. This is the center of mass located at x equal, and then you're supposed to find the center of mass. So here, they have 3 masses. The 3 kilogram is placed at 0. The 5 kilogram is placed at 3. And then the 2 kilogram is placed at 5 meters. Here, the diagram doesn't label what's M1, M2, M3. So it's up to you. I'm just going to go from left to right. I'm just going to call it this one M1. The middle one here, 5 kilogram M2, and then the 2 kilogram would be M3 from left to right. And that you can just apply the same function that I've presented here. Notice the numerator and the denominator has 3 terms because there are 3 objects. Here's m1 x1 plus m2 x2 plus m3 x3 over the sum of the masses. Alright, other than that though, if you pay attention close to the diagram, the 3 kilogram here is placed at 0. So even though there's a mass, it's placed at 0. So really it does not contribute to the numerator. So I wrote out here just for you to see. So here's 3 kilogram. Where is it? It's placed at 0. So x1 is 0. And the second mass is 5. And then where is it? It's at 3. M3 would just be 2 kilogram according to the diagram. And it is placed at 5 meters to the right of 0. And then the sum of the masses on the bottom would be 10. So if you sum all this stuff up, okay, you get 25. The first term is 0 because 3 times 0 is 0, and then 5 times 3 is 15, and then 2 times 5 is 10, so 15 plus 10 would just be 25. The units kilogram will cancel out once again, and it would just leave you with 25 divided by 10, which is just 2.5, so the answer would be the second answer here, okay? Alright, other than that, that is the first 2 examples for this video, and let's crack out one more. Here, you have 3 objects that are located along the x-axis. Very similar to the last one. However, you notice here in this one, the masses is placed to the left of 0, which is fine. So as you do this, pay attention to the position of where objects are being placed. So I'm just going to go ahead and apply the same function I did in the last one. However, pay attention to whether it goes left or right of 0. So here in the first diagram, or excuse me, here in the diagram for the first mass, the M1 is placed to the left of 0, so it's -2. So keep that in mind. And then M2 is placed to the right of 0, and then M3 is also placed to the right of 0. Okay, so the negative sign does matter when you do center of mass. So here M1 would just be 7 kilogram, but X1 would be -2. So I highlight the -2 here because it is important. So as long as you pay attention to whether it's on the left side or the right side of 0, you can't really mess up center of mass for a one linear system. Okay. All right. M2 here would just be 3 meters because that's where it's placed. M3 is 1 kilogram and it is placed at 7 meters to the right of 0. And then once again, all the masses, just sum of them in the bottom. So if you do all this correctly, the top reduces down to just 5, and then the bottom reduces down to just 12, and then 5 divided by 12 will give you a value of about 0.42 meters from 0, and it's positive. So therefore it is to the right of 0. So here roughly I put this little x because this is every increment of 1. So about 0.42, about the center. Okay. All right. Other than that, that is it for this video. So center of mass for one dimension is super easy to do as long as you pay attention in your science. All right. Stay nerdy. Don't be whack.